Hello. Thank you for joining us today. My name is Ben Lorica. I am the Chief Data Scientist and Director of Content Strategy for Data at O'Reilly Media, and I will be your moderator for today's webcast. Full disclosure, I am an advisor to Databricks. Over the past year, as many of you know, Apache Spark has emerged as the most active open source project in the big data space, even more active than Hadoop MapReduce. In our case, in the Strata world, Spark-related proposals have surged. Spark was the top trending topic among submissions for our upcoming conferences in New York City and Barcelona. What's interesting is that many of these proposals came from companies already using Spark in production. Interest in Spark Camp, a training day at Strata in both New York and Barcelona, has been very strong, and we plan to offer Spark Camp at future Strata events. Another interesting thing is that in the second half of this year, the different Hadoop distributions and vendors rallied to make Spark the standard processing engine for big data. And as a further sign of Spark's widespread adoption, we recently announced a joint program with Databricks to certify Spark developers. Today we'll get an update on the latest release, version 1.1, from Spark's release manager. He is probably best positioned to give us highlights available in the new release. And in this presentation, he'll particularly cover things that will help you conduct performance testing and debugging. I've known Patrick from his days as a grad student and researcher at UC Berkeley's MLlib. Patrick Wendell is an engineer at Databricks as well as a Spark committer and PMC member. In the Spark project, Patrick has acted as release manager for several Spark releases, including Spark version 1.0 and the current version 1.1. Patrick also maintains several subsystems of Spark's core engine. Before helping start Databricks, Patrick obtained a master's in computer science at UC Berkeley, where his research focused on low latency scheduling for large-scale analytic workloads. He also holds a BS in computer science from Princeton. I will turn the program over to Patrick in a moment, but first let me go over a few housekeeping things to help you get the most out of today's webcast. First, you'll want to open the group chat widget if you have not already done so. This is where we'll interact with each other during the event and where you'll submit your questions for Patrick. Many of you have good insights and experiences to share, so we encourage you to chat freely during the event. However, if you have questions for Patrick, please preface them with a capital letter Q, so we'll know that it's for him, and we can make sure to see it for the Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget, you'll need to give it permission to access your account. Our hashtag today is StrataConf, all one word, and the Twitter widget will automatically append that to your tweets so you don't have to. If you have any problems during the event, we encourage you to look at the help widget, which is very comprehensive. If you continue to have problems, post in the chat room and one of our staff will help you. For choppy audio or stalled visuals, try refreshing your window. So most importantly, we are recording today's webcast, and we will have the archive ready usually in about 48 hours. And at this time, I would like to turn the program to Patrick for his presentation. Please welcome Patrick Wendell.
Thanks, Ben, for the intro. This is a great opportunity. I'm very happy to have the chance to speak with so many people about Spark in this platform. This is my first webcast experience, so pardon any issues with changing slides and so forth, but I think I've got the nuts and bolts of this. So yeah, as you mentioned, Ben, I'm here to talk about Spark. I'll talk about the 1.1 release, maybe give a few a few indicators of what's coming in the next release and talk a little bit about the state of Spark and kind of how we do releases and some of these more community-oriented things as well. And should have plenty of time for questions at the end of the talk. So I'd love it if this could be an interactive session and I could hear what the people in the audience are interested in kind of knowing. So just to kind of summarize, I'll talk a little bit about myself, Spark and Databricks, about the current release and what's coming up. And I may get to do a demo. I'm waiting on a demo cluster to be made available for me within Databricks. So I think there's a decent chance that will work out, but that will be the ending point of the talk if it happens. Yeah. So about me, Ben gave a great intro, but I am kind of leading the Spark effort inside of Databricks, so oversee all of the sub-teams that work on various parts of Spark. I did release manage this particular release, so 1.1 is very near and dear to my heart. And I've been working on Spark since back in the MLlib days. I was on kind of the original Spark team, joined maybe within the first year of the project, and kind of have been full-time on Spark ever since. So it's been exciting to see the project grow from, a small research project into something that today is becoming just a super widely adopted standard analytics platform. So I'm actually going to start by giving a bit of intro to Spark, and I wanted to send out a quick poll to the audience to get a sense of how kind of familiar people are with Spark and what their background is. So I have two kind of introductory polls. Maybe I'll just do the first one here. So let me see if I can push it. And I believe I have pushed it. 1 second. I see. Hold on 1 second. There we go. So the first question is just about what is kind of your level of experience with Spark? How are you just first starting to learn about it? Are you pretty far down the curve in terms of working on a deployment? I'm just trying to calibrate so I can give kind of a talk that's appropriate for the audience. So I'll give people a minute to fill it out, and in another kind of 10 seconds, I'll go ahead and show the results. Okay, so looks like most people kind of heard of Spark, but haven't used it before. A couple, maybe 25% kicking the tires, about a quarter also working on a proof of concept, and then a small number working on production deployments. Great. So let me do one other kind of initial poll. And this one, I'm just kind of curious what the background is of people in the audience. Are mostly engineers, marketing, kind of sales, business development, or some other category, just so I can make sure I kind of tune the talk to that particular audience. So, all right. Oh, this one, I'm going to push the results right now because the conclusion is unanimous. This is a largely engineering crowd, so that's great. That's the demographic I'm probably most comfortable interacting with. So great, 85% engineering. Okay, so with that background, let me get started, and I will come back to the presentation. So yeah, so a bit about Spark. So what is Spark? A lot of people in the crowd are new to Spark. So sort of at its core, Spark is a runtime, an analytics runtime that works across many environments and provides an abstraction about working with large parallel data sets. So there's a kind of concept in Spark called an RDD, a resilient distributed data set. You could think of it like a data frame or a table or any of these kind of a collection-like abstractions, except it works at very large scale. Any operations on it are inherently parallel, and it also provides sort of automatic fault recovery, which is a property you want if you have data on maybe tens, hundreds, or thousands of machines. So at its core, Spark is really this runtime that allows you to do operations on large data sets. So Spark can interoperate with a bunch of different storage systems. We speak the Hadoop input format API, so we can interact with anything that Hadoop MapReduce can. But we also have a custom sort of input formats for different types of sort of storage and processing systems. And Spark also can be used across many different types of environments. So one area is people use Spark with Yarn and kind of the Hadoop stack, but Spark also runs on Mesos, a different cluster manager that comes out of Berkeley originally as well, and standalone mode, which is just a small built-in cluster manager that we provide, which lets you run Spark kind of wherever you want. So on top of this API, you have a bunch of different domain-specific libraries. And when we started Spark, it was really just the core API, the kind of lower-level blue box. But over time, we realized that we could extend this in many ways to cover sort of specific types of analytics workloads. So what you see today in the Spark ecosystem is many users are actually using these kind of standard libraries and graduating to more domain-specific features. The four that we have today are a real-time library called Spark Streaming, a graph library called GraphX, a machine learning library called MLlib, and a library for dealing with kind of typed structured data called Spark SQL. That one I'll be digging into in the most depth today. But the way that Spark looks now is kind of it's packaged together with these standard libraries. We ship them as one. We've really focused on making sure there's consistency in the APIs and kind of interoperability between them. And this is kind of how you should wrap your head around Spark for the kind of majority of people here who are just maybe getting started with Spark. So that's kind of the architecture diagram. But what's going on in the Spark community? Well, Spark has been an active kind of 18 months for Spark. We've been embraced by all three of the large Hadoop vendors. I think Cloudera and MapR officially offer support for Spark. Hortonworks is now packaging Spark, and they've talked a lot recently about their use of Spark. But I also wanted to point out that I think some people in their head associate Spark as being kind of a Hadoop 2 or something. I think actually we see Spark used in many, many other environments that are not the very traditional sort of on-premise Cloudera, Hortonworks, MapR Hadoop environments. People use Spark with tools like Cassandra on Amazon Web Services. We obviously Databricks have our own product, and people come to Spark from many more communities. Like the Python community, the kind of SciPy, NumPy community. So it's a little bit more, I would like to say that we are touching many more areas than what people typically associate with just the kind of traditional Hadoop stack. So I just wanted to make that point in this slide. It's a very widely adopted project across many different technical areas. So lastly, about Databricks. So what is Databricks? That's the company where I work. So Databricks is providing a hosted analytic platform based on Spark. So it's kind of a very powerful full stack platform with things like table management and interactive analysis, and it's all based on the open source Spark APIs. And we founded it as the kind of maintainers and creators of Apache Spark, as Ben pointed out in his intro. And we're kind of the most active, by far, company in terms of shepherding commits into Spark. So in this release that I'm going to talk about, there was about 1,300 patches, and 97, almost 98% were merged by someone from Databricks. So you should kind of think of us as maybe the stewards of Spark, so to speak, for these days. Now, I want to just note that many people author patches in Spark across the whole community from many companies. So by committing, I just mean that we are the ones who fully sign off and push the patch. But of course, there's tons and tons of people involved in the development of Spark, and many other companies are working on it as well. So now I'm going to talk about Spark 1.1, and to start with that, I'll explain, since it's a developer audience, kind of how we do releases. So we're in a 3-month release cycle, and we scope it based on time and not on features. So we always deliver a release every 3 months. We don't kind of wait for a feature and delay significantly releases for a particular feature. And that's kind of how we do it, because it gives a lot of predictability for downstream consumers of Spark, like you on the phone, the developers. We also maintain older branches with bug fixes, and this actually slide is slightly outdated. 1.1 is now the current release. It's been released, and the previous was 1.02. So just to give you a kind of view of how it works, so the Spark master branch always marches forward. This is us adding kind of new code in master. And when we cut a release, we'll make a new branch for that release. And then within that release branch, we'll add kind of only stability fixes, so things that help make bug fixes. We don't add new features. So those branches just kind of get more and more stable over time. And this is branch 1.1, which is the branch on which the 1.1 release is, which is what I'm talking about today. So broadly speaking, as you go this direction, you get more features. And as you go this direction, you get more stable. And the consequence here is that for people doing kind of proof of concepts, if they're not moving into production yet, we actually just recommend that you take from the head of the most recent stability branch. So for instance, you just use the head of branch 1.1. That will give you even more fixes than whatever the most recent release is. Of course, you're always welcome to just use a package release if you want, but we kind of tend to recommend that for production clusters. But for someone experimenting, we recommend you just get all the most recent fixes. Okay, so what's in Spark 1.1? This is now the slide is slightly outdated as well because we actually had more patches come in, around 1,300. There's about 1,300 patches, more than 200 contributors, many organizations, and you can download it today at the Spark website. So to think that 200 people contributed code to this in only a 3-month period, you can kind of get a sense for how active the project is. It's, we're merging dozens of patches on most days and have maybe tens of people who are kind of full-time involved in Spark as their job. So very active project, and this release represents the work of a lot of people. I'm just the guy who talks about it in some slides, but there's definitely many developers who worked on this code. So the roadmap for both the 1.1 release and the upcoming 1.2 release are fairly similar. So in Spark Core, this is kind of that lowest level of Spark that I've talked about. We're really concerned at this point about usability, stability, and performance. This is a more mature part of the code base. It's a code part where we've sort of guaranteed API stabilization. So now we're just trying to make it as fast and as reliable as possible. And you'll get a sense of that when I talk about the individual roadmap items, but that's kind of the way we think about this component. And then for the libraries, many of which are newer, like ML, SQL, and streaming, we're really trying to expand the feature set and always concerned about performance there as well. But we're kind of there trying to just have them mature into really fully fledged libraries that can be very competitive with any other more sort of one-off domain-specific solution that someone would consider. So to give you a little data point, about almost half the traffic on our mailing list is now about libraries. A lot of these libraries didn't even exist 1 year ago. So you can get the sense of how this is kind of where a lot of the development effort in the ecosystem is going. So now I'm going to go through each component and talk about what's in 1.1, and I'll have a couple slides at the end about 1.2 as well. So in Spark Core, what we focused on for this release, again, it's really just performance out of the box. So we're trying to make sure that it runs smoothly, that it runs quickly, kind of no matter what users throw at it. And in the big data ecosystem, you see all kinds of pathological workloads that users run into. I mean, it's just sort of inherent in the types of just massive and highly varied data sets that people try to crunch. But we try to make sure that even in really tough cases like sorting terabytes of data, Spark is going to perform well. So to that end, a couple things that are of note. One is we added a sort-based shuffle, which the name is sort of describes some internal implementation details, and I'll talk on the next slide about this. But essentially, it's a shuffle that's more robust. So for those who don't know about what shuffle is, it's an internal primitive that's a very important part of any kind of meaty Spark job. It's when we do large-scale data movement. So the sort-based shuffle in Spark is designed to be more resilient in certain situations. I'm going to talk in the next slide, so I'll go over it quickly now. Another thing we did is we added a much more efficient mechanism for this feature called broadcasts in Spark. So this is when you have a single table or data set that you want to actually send a copy up to every node. It comes up in SQL, it comes up in a bunch of other places as well. And we added a version of this that's based on a kind of BitTorrent-like protocol where nodes sort of broadcast data to each other, and it's not a single master-slave relationship. And this actually hugely improved the efficiency of many algorithms inside of Spark. We've added disk filling features to part of PySpark. So this is like if a user has a particular input that doesn't fit in memory, we want to be able to spill that to disk. If they're doing, for instance, a large aggregation and the values do not fit in memory, that feature has been in Spark Core for a few releases, but now we've also implemented it in Python for PySpark. And across the board, particularly in the relationship with Yarn, we've added just general usability and stability improvements. The last things I'll mention are a couple of smaller things. One is that we have this kind of better ability to keep track of progress and define things like counters in your jobs. That's a really a must for certain workloads. And we've also focused on providing kind of really resilient behavior, even in the case of really crazy types of workloads where maybe there's large number of failures in the user code, and we just want to make sure Spark is graceful in those situations. So to give an example of one thing that's interesting, we have this sort-based shuffle. So why does this matter? Well, the way the original shuffle works in Spark is that we actually, when we do a large data movement, we open a very large number of files. We open a number of files that's proportional to kind of the number of maps times reducers. These are basically the senders and receivers of data. And that grows very quickly. It's with the square, essentially, of the size of the data. So the new shuffle uses a very different approach. It's actually a little bit more like the kind of shuffle that's inside of Hadoop MapReduce. And it only writes a single file out for each mapper. Does some kind of sort merging to make this work, but it's much, much better for the file system. And we found for large-scale workloads that this can improve by like 5x the performance, and it definitely improves the stability. So this shuffle was introduced in Spark 1.1. We're going to flip it to be the default shuffle in 1.2, and that's kind of a big change going on inside of the internals. So Spark SQL, what's going on there? So in 1.0, this was really the coming out of Spark SQL. It was a preview release, essentially, for Spark SQL. I mean, the APIs were mostly there, but we didn't advertise it as something that was really ready for prime time yet. It was mostly a preview. And this has really matured a lot in Spark 1.1. So in particular, what we're focused on, for those who were familiar with Shark, that was an early iteration of kind of SQL on Spark. It was based on the Hive code base. We've sort of spun out into a much more sort of agile and efficient design where we actually build a SQL engine just directly inside of Spark, and this was the kind of first really usable release for Spark SQL. Just to give you a little bit of data points around that, in Databricks, our own product, we've actually replaced Shark with Spark SQL and seen kind of across the board performance gains. So we're using this in production for all of our customers, and we can just optimize and iterate on this just so much faster than with the Shark architecture, which was heavily based on a 1 million line code base that is Apache Hive. So we're still fully interoperable with the Hive data warehouse, but we no longer internally use a lot of Hive code. So that's been a big change. I'm going to skip this because it'll show up in the demo. So this is just a little bit of like, here's what Spark SQL actually looks like. You can turn RDDs into table-like objects and query them. I'm going to go ahead and skip this for now, just because I think it's sufficiently covered in the demo. So what's new in Spark SQL specifically? So one is that we added a JDBC ODBC server. This should also say ODBC. It just doesn't right now. And this is to allow you, many types of BI tools and other systems, they speak this kind of protocol of JDBC or ODBC. And this lets you kick up a Spark SQL cluster that sort of can interact with other third-party tools. And it was one of the main things that kind of kept Spark SQL from being up to parity with Shark, is that we didn't have this feature. So now we have it. Another really cool feature we have is native JSON support. So I'm going to demo that in a little bit, and that basically means we can kind of automatically load and understand the schema of JSON data without the user having to ever tell us anything about a potentially very complicated schema. So that's a super cool feature, and I'll be demoing it. We have started towards having a public API for making a schema data associated with RDDs. So Spark SQL, even though the name is SQL, it's really a general way to describe a richly typed data inside of your RDD that makes it much easier to interoperate with. So we've started opening up that API to allow people to kind of define their own types of schemas. We've done a ton of performance optimizations, and in particular around Parquet. That's an area where there's been a lot of community interest and contributions. We have really heavily optimized code paths for running Spark SQL against Parquet data now. So for users who kind of have their data in Parquet or are planning a pipeline where it ends up in Parquet, they'll get really nice out-of-the-box support for that. So moving on to Spark Streaming. So Spark Streaming focused on a couple different things in this release. One is stability improvements. So just, streaming systems are always complicated, and there's many areas in which you can add robustness. So that's been an across-the-board theme. We added support for Amazon Kinesis. So this is a stream processing engine that's hosted as a service on Amazon, and we actually had a few different contributions for this feature, and kind of ended up settling on one of them. But we now support out of the box pulling data from Amazon. A couple other things of note. So rate limiting for streams, that was a very commonly requested feature, and also for Apache Flume, this was contributed largely by Cloudera. We have a sort of high availability mode of reading data from a Flume input source that uses a slightly different architecture than the original Flume integration, which provides sort of better fault tolerance guarantees. So the last thing I'll just mention about Spark SQL quickly is that we've added a couple of streaming linear regressions. So this is the first of what we think will be many streaming machine learning algorithms. This is kind of one of the cool things about running on top of Spark, is that you have this platform where you can integrate stream processing and other types of analytics, and you don't need to go beyond one single project, and that benefits us even as Spark developers. So this streaming machine learning library is actually surprisingly small amount of code. It just is sort of glue between the machine learning libraries we already have and the stream processing capabilities. Lets you write all of this using a consistent API. So this is kind of what's going on today in Spark Streaming, and gives you a sense of what we're working on. So MLlib. So yeah, this slide a little bit small text, so hopefully people can read this. But there's like so much going on, it was just impossible to not put a fairly large slide. So MLlib, interesting subcomponent. It's probably the most active subcomponent in Spark right now. In this release, there's just a huge number, 70 people almost contributed. So to give you some context, like a year ago, we had maybe 70 contributors working on all of Spark, and now we have 70 working in this release just on MLlib. So gives you a sense of this kind of exponential growth in the community. Bunch of new algorithms being added, and some kind of utilities around things like feature extraction. One major thing in this release is a statistics library. So we had a feedback from the community that, gee, we love MLlib for doing various types of machine learning jobs, but there's a lot of just simple sort of exploratory statistics, correlations, hypothesis testing, sampling, and we really like to just do this with Spark, because otherwise we have to sort of offload the data into some much smaller tool like R or a single node Python deployment, and then we have to sample it down to even do that, and it's harder to do kind of accurate things like correlation. So we added a statistics library in Spark, which is designed to kind of let you never have to leave Spark to do various types of sort of basic descriptive statistics on data. So that was a really cool project, and I'm looking forward to seeing people use that. So a couple other things, fairly large performance improvements across the board in MLlib, and I'm going to show a slide on that next, so I'll give that a minute. And in Python, we added a bunch of algorithms that previously had existed in Scala and Java only, and then we ported them over to the Python API. So we're really trying to make sure Python is a first-class citizen of the Spark ecosystem. And you can see we have pretty good coverage there in terms of MLlib. So this is, a somewhat unscientific graph, just to be totally candid. You see some fairly informal labels here, like Reynolds PR and Reynolds PR plus sort. This is a graph that we just did some internal profiling, and the long story short is that the red bars are the 1.0 performance, and the other bars are sort of various permutations of Spark 1.1, and we see like a huge performance increase, as much as kind of 5x in some of the algorithms. So if you're an MLlib user, even if you're not using any of the new features, you should for sure upgrade to the 1.1 because you'll get just a lot of performance. One nice kind of cool thing is that a lot of this comes from performance optimizations that happen just inside of Spark Core, so things that weren't even really specific to MLlib. But that's sort of one of the beautiful things about this kind of packaged ecosystem of Spark, is that you get this benefit of any optimizations that go into Core automatically are realized by all of the other libraries. So other things, so this is the same diagram we had at the beginning, but I just added a few boxes on the left. These are community efforts that are not happening directly inside of the Spark codebase. So I'm not release managing these projects, but I'll give them a shout out. A couple things. One is there's this job server that's from Uyala. It's a way of kind of running a long-lived sort of multi-tenant service based on Spark. That's become pretty active. There's also initiatives to port both Hive and Pig to Spark, being led by Cloudera, and we've come on as kind of advisors in both of those projects, and those are making good progress. And I don't know about the exact release dates for those, so I'm not going to promise things for other people's projects and potentially put them in a bad spot. But I think it's exciting to see kind of these older APIs be ported to Spark as well, and it'll be nice for community members to be able to upgrade without having to sort of do anything and take advantage of Spark. So now I'm going to talk a little about what's coming next in Spark, and you'll see it's oh, you know what? I realized I have I accidentally put a couple of SQL things on the Spark core slide, so we're just going to have to ignore those because you'll see them in a couple other slides. But the largest things in the Spark core are really the things at the top of this slide. So we're going to support Scala 2.11. It'll probably be kind of experimental support in the next version, but it will be a support nonetheless. And this means that the whole ecosystem of Scala 2.11 users will be able to upgrade Spark to that to use with their other 2.11 libraries. Scala has a slightly different upgrade story than Java. For those familiar with Java, you can always just upgrade to the next version and it's backwards compatible. In Scala, that's not the case, so it requires a little bit more work for us to support it. Another thing going on is that we are working increasingly on kind of debugging and instrumentation tools inside of Spark. This is a feedback we've gotten from the community. You know, they want more information about what's happening inside of a Spark job. They want to be able to kind of understand the physical execution of a Spark program, and so we're working on kind of adding better tooling for that. And we've also just continued to upgrade internal components over time. So there's a communication layer we have in Spark, and that's going to be upgraded to be a very efficient Netty-based implementation. The current one that we are working on, we can saturate kind of any network connection that we can find. So I think we're in a pretty good place with that. So in MLlib and GraphX, in MLlib, there's kind of a new API based on data pipelines that we're going to be adding in 1.2. If you look kind of in practice, most of the machine learning work that people do is not in isolation. So it's not like they just want to run one algorithm. It's that they're going through a fairly complicated pipeline that involves training, test data sets, and testing and tuning many parameters. So we're designing an API for MLlib that's really kind of oriented around this pipeline approach to machine learning. And that's going to be a super exciting thing. You know, we will still support all of the older APIs, but we're going to introduce new features for those who want to take advantage of them. And a ton of new algorithms. One that's of note is random forest. It's a very important primitive for all kinds of other machine learning algorithms, so that's likely to end in 1.2. Just to say quickly, for GraphX, we're going to be stabilizing some internal APIs there. Stabilizing our public APIs so that users can know we will not ever change them between releases. GraphX has been up to now kind of an alpha component, so that's going to be a maturity event for GraphX. For SQL, couple of things. So one is that we're going to support Hive 13. This has been a huge request in the community, and so we'll be able to directly read and write data from a Hive 13 metastore. Tons of performance optimizations across the board, and that's just a very common, popular thing in the SQL space. Everyone kind of knows how to make it fast, and everyone competes to make it as fast as possible. We've performed very well in benchmarks already against other similar systems, so we're pretty happy about that. External data sources. So one thing we're working on for SQL is allowing you to really easily just point Spark SQL at anything, Cassandra, Avro data, anything that has kind of a nice sort of well-described schema, and not have to do anything on the Spark side and just load the data with the schema automatically. So kind of a few different large topics going on there. Lastly, just a quick couple notes here. So in Spark Streaming, we're planning to add Python support in this release, which is just a feature that has for a long time been very, very highly requested, and will kind of fully round out our Python support of the stable components of Spark. Also, there's going to be some work around fully HA operation for any input source. So in general, the challenge with these stream programs is that you have many different types of input sources, and they all have different reliability guarantees. So what we want is to offer a mode in Spark where kind of no matter what your input source is, we can do our own kind of logging such that we don't need to make any assumptions about the input source other than just that it's giving us data initially. So this is a fairly large initiative, but I think it'll put Spark Streaming in a really good position around a sort of HA operation. Okay, so now if I dare, I'm going to try to give just a quick demo using Spark 1.1 to kind of highlight some of the features. So let me just go ahead and kick off screen sharing. Now just give me 1 second here. Okay, great. So if anyone can't see what I'm doing, holler to Ben, and he'll make sure that we can get it figured out. But you should be sharing. You should be seeing my screen if everything's going well. Just give me 1 second. Okay, so I'm actually inside of Databricks Cloud here, but first I'm just going to explain the problem I'm going to solve in this demo. And this is a demo, but it's actually also just a problem I really legitimately did solve with Spark 1.1 in the recent past. So what I was trying to solve is this. So for those familiar with GitHub, this is Spark's GitHub page, and if you look over here, we have a lot of pull requests. I mean, Spark is a super active project. We have at any given time like maybe a couple hundred pull requests that are outstanding, and they correspond to all different parts of the Spark stack. This is kind of the main contribution model in Spark. I'm just getting a phone call. I wonder if this is from O'Reilly. Hopefully everyone can still hear me. So Ben, chat to me if you guys are trying to contact me offline. But this is the kind of pull request queue of Spark. And as a release manager, I'm always kind of interested in figuring out what's going on here. Like, what are the various how many pull requests are there for each segment, each kind of component in Spark, and how are we doing? So it turns out GitHub has an API that speaks JSON, and this is a very common thing for many of these kind of services. So if you actually go to the GitHub API for a particular pull request, so this is like pull request 101, I get this nice JSON object that includes, here's the URL of the pull request, here's the ID, and it's kind of this classic like nested crazy JSON structure where it's totally denormalized, and here's the head commit, and then here's a bunch of information about that commit. So this is a fairly common type of messy data problem. There's also a page where I can look at the files that are being modified by this pull request. So this is just metadata about pull request 101, but this is another page that shows me kind of just a list of all of the files that are modified. This file pair RDD functions is being modified, and there was 3 additions and 4 deletions to it, and there's a big list here. So these pages kind of collectively represent the entire sort of graph of things that we might be doing in our pull request queue. But what I want to do is do kind of analytics on this, right? I don't want to rely on just a couple of things that GitHub can show me. I want to actually understand what's going on and have sort of deep access to the data. So what I didn't show, so for those who aren't familiar, this is the Databricks cloud product. So this is running on a Spark cluster, and the cloud is kind of like a notebook-like abstraction. And I'm going to skip through a couple commands because this involves actually pulling the data from GitHub, which I did using Spark, but it has a bunch of my own credentials in it, so I'm not going to show those to users. So I'm going to go to this section where I said start here for running demo. So, hold on, let me just close this. So what I have here is I have a text file. So this is actually a big file on HDFS with, I have 2 of them. So one is called PRs downloaded. The other one is called PR files downloaded. So PRs downloaded is just a huge data set with this screen for every single pull request in Spark. So it's just the kind of metadata of all of these. So just to kind of show you, I can insert a new command here. And if I just do like, take 1 on this RDD, so that's the thing, just give me the first element. You see, okay, I have this, huge ugly JSON blob here. And this is like, this ID of pull request. And here's all the kind of messy data that's associated with this particular pull request. And I can do the same here for this kind of second data set that we have, which is all the pages of broken out individual entries for each pull request. And it's just some ugly, terrible looking JSON thing that seems like it would be really hard to analyze. So what's kind of cool about Spark SQL in this release is we can automatically load a JSON object as kind of a really richly typed RDD. So what I'm going to do is create what's called pull schema RDD. By the way, this is using the Python API, this entire demo. And I'm going to call JSON RDD function and just give it this data set I have in HDFS. So I'm just saying, make a JSON RDD out of this data set and call it pull schema RDD. And it's going to, load and do that. So then what I can actually do is with this RDD, I can print the schema of it. And okay, look, so automatically Spark learned this pretty, gross nested schema, and I didn't have to do anything. I didn't have to kind of tell it all these hundreds of fields and, explain to it what's going on. And I can actually directly use this, whoopsie daisies. I can directly use this RDD now in a SQL query. So I can run something like, select, max number from, sorry, this should be SQL, from, I forgot one other step. So let me just actually put that on pause for a second. So I have pull schema RDD. I'm going to do the same thing for the files. And then I'm going to register them as temporary tables, which just tells, Databricks and Spark just, hey, treat this as a table. So now I can do things like select max number from pull's table. And it's going to give me the kind of maximum pull request number. So one thing I should premise is that this is a development cluster, so it could get restarted. I have no idea what's going to happen to this cluster while I'm running the demo. So if anything weird happens, I promise this is just a development cluster, and I have no idea if other people are working on it. But so what I did now is I just said, okay, show me the maximum pull request number from this table, and it can give it to me. And this is all just using SQL, which is pretty cool because I never defined a schema. I never really entered this in a rigid way into a database. I just put it to a bunch of JSON files and said, learn the schema of this and let me query it. So now I'm going to do something a little more complicated, and I'm not going to go into the details of what this is doing, but what I want to do is kind of categorize each of the pull requests by which part of Spark it's modifying. And how I do that is that I'm going to look in the file. So this is that second data set with just, this file was modified in this pull request, and here's how many times it was changed. And I'm just going to look at the file name that's modified and do some regular expression matching on it. So this is something that doing in SQL would be a little bit awkward, so I'm going to actually use Python for this and just use the native Python Spark API. And what that boils down to is just an accessory function here. I just have a Python function that, it gets this pull request, and so we're accessing directly fields like pull request.files. Again, this is the notion of the schema, and we never had to define it. We're just using it directly. And we're saying, does the file name match the word SQL, and if so, yield a tuple with the additions and deletions in the file name. This is don't worry about the context of the function. But the nice thing is that I can do this using Python, because doing this particular transformation in SQL is actually quite difficult, because I have this kind of data set where each item is a set of sort of an array of objects. And doing operations on sort of array types in SQL is really awkward. There's something in Hive called like a lateral view explode, which will let you do this. But when I was working on this problem, I actually spent like 12 minutes trying to figure out just how the heck I would use that operator, and was so annoyed that I just thought, hey, it's a lot easier in Python to just iterate over this thing as a list, and I can write a Python function to do regular expression matching. So I did that. So what this gives me, and this is just a boilerplate to actually run this thing. So it gives me a table called files collapsed. And now I can go back to SQL land just to see an example and just select star from files collapsed and look at just where, I happen to be looking at this particular file name. So, so if you look, there's 4 different pull requests that have modified this file. And here's how many kind of additions and deletions they had, and every one of them was categorized as MLlib in the previous transformation that I did. So I'm going to, I'm going a little bit more quickly now, but I'm just trying to give you the sense of how do I get kind of an end-to-end problem solved with Spark SQL. So now what I want to do is that if you remember, I kind of have 2 data sets. I have this one of all the individual pull requests, then I have this one composed of all of the files that were modified in a pull request, and I've done some tagging that sort of adds a notion of which category this is from in my own Python code. So now what I want to do is kind of join these 2. And for those familiar with kind of join syntax, this is a HQL style join, where I just say make a big table that now joins each pull request with all of its oopsie daisies, I scrolled away from it, with all of its individual files that were modified, and so now I have kind of the big table, which is what I want to look at. So just to show you, so if I do like select star from polls with categories, limit 5, just to kind of show you, so what did I actually produce here? So I produced a thing where now it has the category of the pull request. It has the number of the pull request. This is the very first one that ever came out of Spark. But now it's sort of been joined with this notion of what files are modified. And so I have a table that has both every file that was modified and its category, which is ultimately what I wanted to ask out of this data set. I wanted to say kind of how many patches and lines of code are being proposed for each component. And so now I can get to kind of the final question, and that's what I'm answering here with this query. I want to select the category and the sum of all kind of the code difference, so that's how many lines of code were added minus removed, from the polls with categories, which is this big table that I just made joining these two data sets. And I want to only consider ones where the state of the pull request is that it's open. So I can run this. And actually, one nice thing is, so by default, I just get a table back. So I have, Python is, this many, Spark Streaming has this many. But what I want to do is actually plot this. So here's me turning this into a plot. This is a feature of Databricks Cloud, so this is not available by default in Spark. But in Spark, you can get a table and then plug it into some, whatever plotting framework that you like to use. And the takeaway here is that if you look, most of the pull request entries are Spark core, and then it kind of trails, there's like SQL, and this green one is just documentation updates and MLlib. So I can ask these kind of questions. Actually, I realized I switched to a different query, but they're almost identical. This one just selects the count instead of selecting the number of like lines of code added or removed. But it produces very similar results. So let's actually pop out the other one as well. And these are just simple kind of analytics queries on this data set. So here we have the one that's based on lines of code, and you can see it's actually a little bit different. Here, MLlib is very highly dominating. So the corollary here is that for MLlib, there's fewer patches, but the patches are overall much larger because in this graph where we're just looking at the count distinct of how many patches there are, there's a smaller wedge for MLlib, but in this patch where we look at actually the code added, there's a much larger wedge. So that's actually pretty consistent with my understanding, because I know in MLlib people like to add full algorithms as a patch, and that tends to be like maybe hundreds of lines of code. So anyway, this was a pretty quick demo. I just wanted to give people a feeling of just starting with a really raw data set, right? We started with this, clunky, very deeply nested JSON data set, and just using Spark and Spark SQL, we went from that to a really nice kind of result here, which is that we've done this tagging of every single piece of a file that was modified, and put them in these categories, and then we can look at the categories and see kind of how much was modified in each of these. So that's just kind of an end-to-end demo of just some of the stuff in this version of Spark. Keep in mind there's tons of other stuff that's even unrelated to Spark SQL, but that's like kind of one that I've been using directly, so interesting thing to demo. So I had a couple slides about performance stuff, but I'm actually going to go ahead and skip those. It's not super important to the topic of the discussion, and I do want to leave like at least 10 minutes for questions at the end. So yeah, just a couple things here. If you want to learn about Spark, there's the Spark. Oh, I got to push this slide. So if you want to learn more about Spark, there's the Spark website. If you are interested in learning more about Databricks, there's our website, and I'm on Twitter as well. I usually tweet about Spark. It totally annoys all of my friends who do not care about computer science or engineering, but yeah, feel free to follow me on Twitter if you want to learn more about kind of what we're up to at Databricks and stuff that I work on. So anyway, so with that, this has been kind of a lot of information, but hopefully gave you a good sense of what's going on in Spark 1.1 and what we're working on next. And I will hand the mic back to Ben to field questions from all of you.
All right, thank you. Great presentation. Great demo at the end there. We have a lot of interesting questions. Let me go through them. I've grouped them. And let's go through them systematically here. The first set of questions has to do, so this might be people already familiar with Spark. So in terms of upgrading from one version to another, in particular going from, say, 0.9 to 1.1, are there particular gotchas that people should look out for?
Yeah, that's a great question. So, what's the deal if I want to upgrade Spark? So a couple of dimensions to that, and I'll just talk about each of them quickly. So what is the binary compatibility story? Like if I wrote an application against Spark 1.1 and then I run it against 1.2, do I have to change my application, recompile, and so forth? So within the 1.0 line of releases, we actually have like strong binary compatibility guarantees for all of the components that are not marked as experimental. So this excludes some of just like the very newest things like GraphX. And we try to be very clear about how we're kind of marking these. So from a code compatibility perspective, if you're within 1.x, you're fine. If you're upgrading from 0.9 to 1.x, then there are some changes, but we have them very clearly documented in the Spark 1.0 release notes. So definitely go there to check it out. Within 1.x, you should be fine. Of course, there are new features that you're welcome to try out, but if you just want to preserve your existing workloads, you should always feel comfortable upgrading. You'll get the benefit of a lot of optimizations, et cetera. So yeah, I think we have a pretty good story with that in that regard.
So you talk a lot about Python and SQL, but there's some in our audience who are interested in R. Can you just give the lay of the land as far as R and Spark?
Yeah, for sure. So there's a project called Spark R that's working in the MLlib, but we're also actually helping contribute to it at Databricks. And in the long term, Spark R may actually be merged into mainline Spark. For now, it's sort of a separate project, but it's worked on by a Spark committer, and we're very closely involved in it. So Databricks has actually partnered with a company called Alteryx, which itself has a product that exposes R to its users. And Spark R is continuing to be developed. In particular, what's on the roadmap there, one thing is having a better ability to call these new machine learning algorithms that we're adding inside of Spark directly from R. And so those are kind of some of the things that are most important in that ecosystem. I'd like to see Spark R merged into mainline Spark in the future. It's probably not ready quite yet, but it's a fairly active project. So definitely a lot going on in Spark R, and we are contributing to it from the Databricks side, and Alteryx is also spending quite a lot of effort on it.
So can you just give a quick overview of what people can do now as far as if there are users and Spark, as far as you know?
Yeah, sure. So Spark R is actually quite similar to early versions of PySpark. So the basic idea with Spark R is this. Many users, they're comfortable with the R programming language. They're used to using kind of single node R deployments, but there's obvious scalability issues with that. So what Spark R lets you do is it lets you sort of sit down, drop into an R shell, the R sort of programming language, and run even sort of larger scale Spark jobs using actually the core Spark API. So you're running on top of Spark. And a common use case here is like, I have a large data set, and initially I want to do some exploration and do some kind of basic statistics, and then I might pull a smaller result set directly into R to do some kind of more complex algorithms that are only supported on a single R node. So it's kind of an R front end for Spark is how you should think about it, and lets you kind of have the access of the full Spark API, even running on large data sets, but also pull results very natively directly into R to do kind of subsequent processing on R itself. I think the future of Spark R is pushing more of the functionality into Spark. For instance, being able to run kind of distributed versions of a lot of the algorithms in Spark itself, and kind of allowing the user to do that in a very native way. So that's kind of what the project is from 10,000 feet.
Yeah, and it seems like actually the stuff that's being done in Spark SQL will be useful to our users down the road, things like schema RDDs and things like that.
Exactly. So where this is all going is towards kind of a unified data model that looks a little bit like a schema RDD and a little bit like a data frame. And I think unifying these data representations is something that's a very important thing for us in Spark. And you'll see action around that in the future.
So there's quite a bit of questions about Spark SQL. So actually, before I get into it, so in your interaction with the Spark community, what do you think people are most interested in?
What are people most interested in? Well, it's pretty clear the two most active, in the last release, the two most active projects were Spark, SQL, and MLlib. So, in terms of looking forward, that's what my feeling is. That's what people get excited about. They're the newest libraries. Everyone is excited about them. I think a lot of people are also excited about just us making Spark a really reliable kind of workhorse and being able to throw lots of different workloads at it. I think this is kind of the main thing I think people are excited about, as far as I can tell.
So, in terms of Spark SQL, so we talked about people using schema RDDs and they may evolve into data frames for machine learning and stuff like that. But there are natural synergies between Spark SQL and Spark streaming as well, right? So people are asking if they can use SQL to query streaming data, for example.
Yes, for sure. That's a great question. So one nice thing about having this schema RDD is it's really a sort of intermediate format that all of the libraries can understand. So we do support kind of basic querying of stream data now. So for instance, if you're producing a new stream, a new schema RDD every 60 seconds, or every 100 seconds, or every 60 minutes, you can run queries over even kind of like a windowed schema RDD. One thing that we haven't added yet, although it's clearly going to come, is actually having support for SQL operators that are specifically pertaining to Windows or streams. There's no real standard for this because the SQL community never really created one, but there are some SQL variants that actually support sort of defining and querying streams in SQL. That's something that we haven't supported right now, but we do support now. If you define your stream using the normal Spark Streaming API, you can then query it using the Spark SQL API, which is pretty cool.
So can you comment on the Spark SQL support for Parquet and partitioning files in HDFS?
Yeah, so we do support Parquet, and we also support partitioned Parquet. That's a mouthful. We also support partitioned Parquet files. So this is, when I said we had kind of native support, this is specifically what we've focused on optimizing, is having really fast access to native, to just Parquet files that are sitting there with a kind of traditional partitioning setup.
So there's also some questions, right, asking you to compare Spark SQL with other SQL and Hadoop options, which, I think the big ones out there are Impala and I think more recently Drill, right? So I don't know if you want to do that, but I think that I think at least that the MLlib has done benchmarks in the past that might be updated in the future, let's say.
Yeah, for sure. So let me, that's a whole talk in and of itself, but I'll just give a couple of high-level thoughts. So Spark SQL is slightly different than most of the other systems that you see, except for Hive, because it's built on top of just the more general Spark engine, and it's designed to be kind of interoperable with all the other Spark libraries. So in terms of performance, I think, if you look at even some of the recent benchmarks, Spark SQL has only existed for like 4 months, essentially. We've only had it released for a very short amount of time, and already it's the fastest system on the JVM of any of the other SQL engines, and at least in every benchmark that I've seen. So I think we're really focused on having good performance, and being built on Spark is a big part of that. So I'm excluding their Impala, which is kind of a from-scratch C++ based a query engine that's really, really specifically designed for doing TP-CDS style workloads. So of course it performs very well in those benchmarks. So I think we have a sort of a different feel than most of the other SQL engines, and I'd like to think we're extremely competitive in terms of performance there. But of course, users need to do their own benchmarks, and they need to evaluate these systems on their own. That's always the best way to know what to use.
And I think a lot of people loved your demo in terms of taking that JSON file and just getting so much done from simple SQL.
Yeah, it's really, it's just striking how hard it can be sometimes to just do a fairly simple thing when you have messy data sets that are in textual format, have deeply nested schemas, and so forth. So this was really something that I actually did with Spark, and I kind of came to that conclusion pretty quickly, which was definitely cool.
So some questions about the interoperability of Spark SQL and Parquet files with protocols like Thrift and Protobuf? Are those
Yeah,
switches for now?
so there's a little bit apples and oranges. Parquet has kind of its own storage format. We're really focused on kind of that storage format rather than Thrift or protocol buffers. Although I think over time we'll add kind of nice connectors where if you have files that's in, say like protobuf sequence files, you can easily also query those. But I think like initially the kind of native support we added was for Parquet specifically and its own storage format.
So there's a set of questions about deployment. So the first one, basically there's a couple of them. One is for people using Amazon Elastic MapReduce, what's the quickest way to get started with Spark? And then generally, I think, Patrick, there's questions around, configuration and documentation for configuring your Spark cluster. Where can you refer them?
Yeah, great. So a couple, kind of two different sets of questions there. So question one is, I'm running on Amazon, maybe I use EMR, what's the best way to get started with Spark? So for there's two things I can recommend. Probably my first recommendation would be Spark has these EC2 scripts that we bundle with Spark. Just Google like Spark EC2 scripts, you'll find the documentation. And we run Spark on EC2 all the time. It's a very, very popular way of deploying it. This lets you start up a cluster quickly. You can use spot instances and so forth. So I would recommend checking those out. It's a very widely used feature. Second thing is that Amazon itself has an Elastic Spark service. It tends to run slightly behind the kind of most recent version, but they'll support it, and they've had that for a while. So that's another thing to check out. Candidly, I think the Spark EC2 scripts are much more popular than the Elastic Spark, but I know that there are people who use both of them. So depending on which one is more of a fit, you should check those both out. The other question was deployment and configuration. What the heck? Where can I find out about this? So yeah, I mean, this is obviously a huge challenge for any of these systems, especially something like Spark that integrates with many other systems and environments. Is that deployment and configuration. I would recommend checking out the documentation in the Spark project. We put a lot of effort into providing good documentation on the Spark website. Another resource is mailing lists and also mailing list archives. We have a very active list. There's hundreds of people on it every week, and if you have a problem, it's likely someone else has had it before. So don't hesitate to go to the list and check it out. And lastly, I'll mention there is an upcoming O'Reilly book about Spark, and one of the topics in that book will be configuration. So once that's available, I think that's kind of the next chapter to be released in the book. That would be a good resource for people as well. I am planning to write that chapter personally, so I'm putting in a shameless plug in that regard for that. So these are kind of the main resources I can think of for people.
So some people, I think, took notice that you didn't spend too much time on GraphX. So they're asking what are the plans for GraphX? What's the cadence for enhancements in terms of that component?
Yeah, for sure. It is true. One thing is that it's hard to cover everything. So I didn't, for instance, I also didn't talk in tons of depth about PySpark either. But for GraphX, I think the reason why I held back a little for this release in the marketing around it is because a lot of stuff is coming in the next release. So it's graduating to a stable API in 1.2, and there's also some machine learning components that are going to start using GraphX internally as kind of to do some algorithms that are much more better expressed as graphs than as other data types. So in 1.1, there was just mostly optimizations and fixes. So it was largely about kind of improving the stability of the existing API. So a lot more coming on that in the 1.2 release.
So a lot of people also noticed the beautiful notebooks that you were using, and obviously those are the data from the Databricks workspace, from Databricks Cloud. But some people couldn't resist wanting to ask, are there plans to open source these notebooks?
That's a great question. So we get this question all the time. I would say we have not sort of committed one way or the other at this point on open sourcing Databricks Cloud. It's currently not open source and probably wouldn't in the short term, but I think it's something we might consider longer term. If you don't want to go through Databricks Cloud, which is completely legitimate, especially since it's not generally available right now, people also chain together things like IPython Notebook with Spark, and there are ways to make a notebook-like thing work well with Spark. But Databricks Cloud for now is more of a product than an open source project.
All right. So with that, we want to thank Patrick for a great presentation, and we'd like to thank all of you who attended our webcast today, and hope you benefited from Patrick's great presentation and demo. This concludes today's webcast, and as I mentioned, we usually have this archived and ready to be watched in about 48 hours. Goodbye.